Hi, everybody. Welcome to our webinar. I'm just going to give everyone a minute to get set up as we kick off today for the Pepsi 3D Printing Challenge. Get comfortable, get sorted, grab a Pepsi maybe, sit back, and we hope you'll enjoy this excellent conversation with our team. Oh, wonderful to see you in the chat, Franco. And that reminds me, please do feel free to participate in the chat throughout this event. We will be keeping an eye on the chat as well as on the Q&A. We'll be answering questions live throughout the event and with a special dedicated time for Q&A at the end of the webinar presentation. We'll be starting in just a minute. I do see lots of people joining us, including from Portugal. Hi, Pedro. Welcome. We're really pleased to have you with us today. So as people keep signing on, I'd like to remind you today's session is being recorded live. And it is being recorded. Everyone who is registered will be receiving the link to watch the replay. And we hope that you enjoy this content available live as well as on demand. Thank you, Christopher. We're happy to have you here from London. Throw your comments in the chat throughout, questions for any of our panelists from PepsiCo, from Dynamism, from Henkel, from Nexa 3D. Anything that you want to know more of, let us know. You can say the Q&A box at the bottom of your screen. We welcome you to use that throughout today's event. We will be addressing as many questions as we have time for during our allotted time. We have a lot of material to get through, so we do hope that you're comfortable. And I can see that we're already kicking off, so it's really great to see people coming in with questions, with chats, and just getting sorted. So it looks like we are starting to stabilize with participant numbers. We're so happy to have you all joining us live. So let's get started. Welcome everyone to today's webinar. It's a live session presenting the Pepsi 3D Printing Challenge. We're going to be talking about everything it took to achieve remarkable savings in terms of time, cost, energy, and everything else that goes into product design, which, as I'm sure you all know, is quite a lot. And when we're talking about 90% plus savings, very significant when it comes to business. So let's dig in today about how everything has panned out for PepsiCo. And I'm sure you know PepsiCo. We're going to look at how this huge global company has streamlined their blow mold development process from 4 weeks to 5 days with the help of 3D printing. And we always want to be clear, it's not just 3D printing, it's a huge process. There are a lot of people involved in building to the success. So I think it's about time we meet all of the people involved in this process. So before we get too deeply into the slides, I'm going to stop sharing and draw your attention to the people joining us live on the screen. And I'd love to invite all of our panelists to introduce themselves. So why don't we start with the team from PepsiCo. Max Tangtip, would you please introduce yourselves and your company?
Sure. So good morning, good afternoon, good evening, everybody. I see a lot of people from all over the world, which is great. My name is Max Rodriguez. I lead the Advanced Engineering and Design team, part of the Global Beverages R&D group located in Valhalla, New York. And just a very quick introduction about PepsiCo for those. I think everybody knows the company, but again, we're a $79 billion net revenue company with over 335,000 employees, with the presence in over 200 countries and many, many billion-dollar brands. I'm sure some of them are even your favorites. And with that, I'll pass it over to my colleague, Tangtip.
Thanks, Max. Thanks everyone for joining today. So my name is Tangtip T. Cannell. I'm a part of Max's team, leading the advanced rapid prototyping pillar as a packaging engineer. And within this team, our focus is looking at new and emerging technologies within additive to really fast track and accelerate our package development process, which you will learn a little bit more later in this webinar.
Thank you, Max and Tangtip, for introducing yourselves. And I don't think we would know each other if it weren't for our reseller Dynamism. So I'd love, Fratch, if you would introduce yourself and your company and what you do for this world.
Hello, everyone. Thank you, Sarah. I work for Dynamism. Dynamism is an additive manufacturing solution provider. I head the industrial sales here at Dynamism. Our goal is to help customers with our expertise. We represent several different technologies. We're agnostic about which we sell and how to help our customers. With each technology, we try to have best of class, and therefore Nexa is one of the top of our products. Thank you.
Thank you so much. It's always a delight to work with you. And of course, a platform is nothing without its materials. So one of our primary material partners is Henkel Loctite 3D printing. Sam, can you introduce a little bit about who you are and what you do?
Yeah, thank you, Sarah, and good afternoon, everybody. My name is Sam Bale, and I work for the Henkel Corporation. I'm the head of sales and partnerships for our Loctite 3D printing division, dedicated group of developing photopolymer materials for additive manufacturing. Thank you.
So thank you, Sam. And I realize I haven't introduced myself. My name is Sarah Gerke. I'll be our moderator and host today. I'm our Senior Director of Strategic Communications and Ecosystems at Nexa 3D. We are an OEM producing 3D printers, ultra-fast photopolymer and polymer production focused. And the systems that we're talking about today come from our photopolymer portfolio. It's the NXE 400 platform that we'll really be digging into a lot. I'll provide a little bit more detail and ambiance about what it is that we do in this industry as we get through here. But what we're really here to hear about is how a huge name like PepsiCo has put 3D printing technology to work, and everything it took to create new bottle development, new product design within a week. So we're going to go back to looking at a pretty awesome animation here. And this is from PepsiCo. So Tangdeep, Max, I would love it if you would be able to dig in a little bit to what's going on here. What are we looking at? What have you designed, and what are we talking about today?
Yeah, I can give a little more in-depth detail into our patented modular mold set. So this mold set utilizes a combination of both additive and subtractive manufacturing, as you can see here. The metal housing is universal, and it fits into most standard blow molders. And then we only print out the cavity inserts to reduce the overall print time and, of course, material usage. So because of this, we're able to print inserts for various bottle designs ranging up to 1 liter. And this design is also scalable to multi-serve bottle sizes in pilot plant environments. So after the 3D printed cavities are assembled, we use this filler material, which gives us that compressive strength required for blow molding, allowing this mold set to be essentially printer agnostic. And of course, the printer technology used will determine the number of cycles that this mold can withstand.
That is pretty incredible. So it might seem like a little bit of an obvious question, but why is speed important to the design process and everything that you're doing? How does technology really come into play for a global giant like PepsiCo?
I could take that question. So in the past, if we compare it to the past, the way that we did package development, normally we would be working with our industrial design team and looking at several concepts which emanate from a consumer insights to a sketch, to ultimately CAD designs and the multiple iterations. But you need to actually put it into the hands of our critical stakeholders before we go into manufacturing. And that can often take time, sometimes even months, with a development cycle leading into 12 months to 18 months in our normal operations. So anything that you can do to try to reduce that process by getting decisions earlier on, by getting the physical samples in the hands of those critical stakeholders is a significant benefit, because it speeds our capability to get to market quicker and ultimately gives us a competitive edge.
The you know, it's just really cool. It might not be the most technical term for it, but it's really cool. So you developed a patented modular mold design system. Can we walk through a little bit what that looks like for PepsiCo and why it's important to companies like PepsiCo that might be doing things like relatively frequent product design? I'm going to scoot over here to the next bit of the workflow, and I'd love it if you would both be able to take us through this.
Yeah, so in terms of our workflow, we use, a variety of interlacing technologies to really fast track that process to get us to a product by day 5. So what we're looking at here is our CAD generation toolkit for automating the process of creating the 3D CAD models. And this is a plugin that's within SolidWorks, and we've designed and engineered it to make it user friendly, so that anyone with very minimal SolidWorks expertise can go in and run this plugin in a matter of minutes. So we've reverted from manually creating the CAD models and then prepping it for printing to fully automating that process to generate files or generating the CAD models for printing.
And if we move into the next bit of the workflow, we see something pretty interesting here.
Yeah, so in parallel, to meet that 5-day timeline, we also utilize simulation softwares, in this case, stretch blow molding simulations, to conduct hundreds of cases of DOEs for varying process conditions. And then, by day 3, we're able to get a baseline recipe ready for blow molding. And then, in the meantime, the parts are printed and then assembled into the mold kit.
And moving forward, we see even more of the workflow going on here. So I'm going to take just a minute to highlight this video that you at PepsiCo have shared with us about what the entire process looks like. Would you be able to walk us through this a little bit? Well, what are we seeing?
Yeah, so this video, it showcases our toolkit that was designed in development with our business partner BMT, that it mates perfectly with our modular mold set as well as conventional metal molds. And as you can see here, the assembly and disassembly of the mold is fairly straightforward. So by day 4, by day 3 and 4, we have a fully assembled mold set with a baseline recipe to start with, and then we get into blow molding the actual bottles. And these are fully functional samples, so we're able to fill, cap, and then use these for physical testing as well as downstream activities such as like line convey, vent testing, things like that.
Awesome. And we'll pause there for a second because I know that PepsiCo patented this process, right? It's a really cool process that you developed in-house to solve all of the problems that you were seeing, all of the challenges, and how to really break into that area of new product design for such a busy global company. We know that everything that you've done has been in your best interests, and you had to evaluate a lot of technologies to get where you landed today. Can you tell us a little bit about what that process was like? And also, as we get into that process, I'd love to hear from Dynamism, from Fratch, what the process looked like from your perspective. As you worked with PepsiCo, how did that relationship develop and evolve and bring us to where we are today in evaluating and validating designs?
Yes, Pepsi had reached out to us early in 2021. It was the beginning of the year. They presented us with some of the challenges they were experiencing during that time. Obviously, the biggest criteria was the material need, and also as well as the build platform and print speed. It was pretty easy to narrow down the option and go directly to Next, where we were able to provide the largest build platform in the resin industry. as well as bringing in the Loctite X-Peak material to kind of complete the whole package. Working with Tongue Hip, it was a pleasure. They were able to share some of their STL files. Our applications team was able to utilize the equipment that we have in-house to print several different iterations of the product. And then we shipped it off to them for testing, and the rest is pretty much history.
Fantastic. And Tongue Tip, Max, can you share a little bit about what it was like for you to work with Dynamism and what that looked like for you as you started looking for the best fit, the best tool for the job?
Yeah, Tecta, do you want to go? You want to take this one?
Sure. Yeah, it was a very smooth transition. I mean, we've had a, we've been working with various printers for this application, and it really came down to identifying a printer that can allow us to print all three components in one, and then also, meet the material properties that we were targeting. So when we worked with Dynamism, the solution was right there, and we were able to kind of shift all of our learnings from other printers into this printer very seamlessly.
Awesome, thank you. So while we talk about what you landed on, we know it's a printer agnostic process, and that's really important for you as a company to be able to always use the best tool for a job. And I think by now, especially in the additive manufacturing, we've all heard the aphorism that when all you have is a hammer, everything looks like a nail. But that's not the best way to get things to happen, right? So working with Dynamism and Hratch and his team, their ability to really bring you up to speed on lots of options out there and the different results and times and value and return on investment you could expect to see. I know I'm really proud of our team that it was the NXE 400 platform and our LSPC technology that brought you the results that you needed to see, and that was something that we were really able to bring to you. So I would like to just take 1 minute, to share with everyone joining us today what it is that LSPC technology means. It's lubricant sublayer photon cooling, and you need all of these things. So it's a resin technology. There's uniform production with distortion-free illumination. You can see a little bit of everything that goes into it here. Our secret sauce is really in our LSPC membrane. The peel-off forces are a huge, huge factor when it comes to resin 3D printing, because it sticks to that membrane, that platform, as every layer continues to come. So the speed at which things can actually come off it really informs the speed that you'll be able to get good, repeatable, high accuracy, high value throughput for what you need to do. But when we talk about speed and production at Nexa 3D, we don't just mean print speed. And a lot of people kind of stop the conversation at speed. And we say 20x productivity. That doesn't mean 20x print speed. Our print speed is about 6.5 times what you'll find on competitive resin 3D printers on the actual printers themselves. But the actual throughput is this full end-to-end process, and that's where we really need to focus. And end-to-end, it means identify, evaluate, prepare, produce, wash, and cure. We can't ignore any step throughout this process. There's really a very lengthy process that informs everything that additive manufacturing is today. And it's that end-to-end process. You need these different factors when you actually look into that math. And if you check out nexa3d.com really soon, you'll see our 20x productivity white paper, because it's about time. That's what we really offer you. That 20x comes in through the math worked out from print speed, build volume, the wash time and the cure time, and then getting your actual finished part off the line. And so when we look at everything that was able to happen to come together here for PepsiCo, what came into play was that larger build volume, having that industrial capability with an ultra fast print speed, with that end-to-end wash and cure everything mode coming in. Fratch, you and your team at Dynamism were really able to exemplify what that could bring to the team at PepsiCo. And we really value the thoroughness of evaluation that you were able to bring to the table, because we want you to look at your options. You know, we want you to see what else is out there. This gorgeous blow molding application that the PepsiCo team designed and patented is, you know, very, very intentionally agnostic. It doesn't rely on a single print technology. It doesn't rely on a single platform, a single material, but it's finding what works best for what you're doing. And so that really resonates with what we're doing, because what we want to do and what we want to offer you, and to anyone who approaches our technology, who approaches our platform, is to get the speed of a full end-to-end solution and that actual throughput, that actual realization of success and what that means to you. And obviously with anyone, that looks different. But one of the things I think that you've all driven home that makes it look different, I know, Tangtip, Max, you worked with a lot of different materials for those 3D printed inserts for your blow molding process. And, you know, I'll leave it to you if you want to talk about a little bit of the materials and processes that you worked with, and we'll leave a little bit of room for that as you consider, you know, how much you want to dig into that. But one thing that's really special about what we're talking about today is the entire platform that you were able to bring together, and what Fratch and his team at Dynamism were able to sink in. And that includes our materials partner at Henkel Loctite. So Sam, the material in question today for this particular application is XPeak 147. What is it? What does that mean? What is the XPeak 147?
Sure. So XPeak 147 is our essentially our high HDT resin. As you see on the slide here, we publish an HDT of 238C, and actually, just to let everybody know, through some additional ASTM testing, we're actually now are recertifying up to 290C. So really in the industry, what I think makes this product quite unique is one of the highest HDT one component materials. So there's no mixing. Essentially, you use the product just as a one component material. You'll see it has good tensile strength, Young's modulus, a low elongation. And what really makes it kind of unique is also it has a low water absorption and good low coefficient of expansion. So, we've seen a lot of success in these types of applications, molding applications. And of course, through the work that we've done with Nexa in really optimizing a workflow, we're able to obviously guarantee that a customer, can achieve these results, and really has wonderful sort of print definition. So my assumption, something that the Pepsi team really liked, is that, through their design iterations, they're getting really good definition of detail, which really comes with, the uniqueness of the printer and the way our two teams, Nexa and Henkel, have worked together to optimize the process. So good dimensional stability, good surface finish, and my guess is the high HDT is really what's stood out for this application. And as you see in the picture there, this is actually a similar application where mold sets are printed for low pressure injection molding. So this is an application that for actually a Henkel material that we use for injecting a polyamide material. We call it a technomelt, where you overmold electronics. And same thing, we've printed the mold set So I think that's really what makes this product unique, and my assumption why it was selected by Dynamism and Pepsi for the application.
I love that. Sam, if I could just pick your brain for a minute here on that while I have you. Well, we
Okay.
all have you. XPeak 147 is a really interesting material. Can we go in a little bit into, its genesis, the material itself? Why was it brought to market? Was it applications like this? Did you, kind of see in your crystal ball that companies like PepsiCo would be needing a high heat mold material? Why, what was it about XPeak 147 that really made this material evolve, come to market, and relevant for platforms like ours at Nexa 3D?
Sure. Well, I think the genesis of the material is as we were launching, different materials, we look across the spectrum of, what are those spaces that industrial customers are looking to fill. I think as we all know, right, people sort of revert back to materials like, an ABS, traditional plastics, and sort of those unique properties. I think in this case, it's interesting, that Nexa has sort of aligned this to PEEK, a polyether ketone, where, you obviously have a product that has low moisture absorption. And again, really the genesis was to develop a high HDT material. As we see, there's lots of applications in, automotive, under the hood, things where there's a lot of thermal cycling, yet you need to have really good dimensional stability at temperature or through a thermal cycling process. And so that's really the genesis of this material. What's also interesting is this material is actually becoming sort of a base set for us as we go to other materials. We recently launched an ESD material where, again, the XPeak 147 is sort of our, I would sort of say, a base resin, just due to those unique properties. But yeah, essentially that's really the spot we are trying to achieve with the resin, and continue to work in that space and work with Nexa as we get feedback from the industry and from Nexa on really what customers are looking for. We obviously go through those design iterations with you to come up with unique materials for the platform.
Absolutely. And it is a pleasure always to work with the Henkel Loctite team in our next factory, as well as in additional material development for what works best on ultra-fast 3D printing platforms. We do have a question coming in, Sam, that I'd like to bring up right now, while we've got you kind of focused on this XPeak 147. John Henrique Bergon asks, how are the chemical resistance properties of XPeak 147 and also the compression strength compared to regular PEEK? So if that's something we can dig into a little bit.
Yeah. So unfortunately, I wouldn't be able to answer the second part of the question. It's compression strengths to traditional PEEK. I probably have to go back and speak with the engineering team and see if we've actually done any of that or have any of that data. But in terms of chemical compatibility, again, I would refer to our technical data sheet. One of the things that I'm, quite proud of at Loctite 3D is we obviously do a lot of diligence in testing our materials to sort of industry standards. So things like motor oils, acetones, IPA, gear oils, other sorts of chemicals. We actually do real-time testing and publish that data, especially at certain hours. So you would see 500 and 1,000 hours of data. In general, I will say, yes, one of the benefits also of the XPeak resin is it does have very good chemical compatibility to a lot of traditional industrial chemicals in a similar fashion to PEEK. So it has, very good chemical resistance. And specifically, if you're looking for a specific chemical, you can refer to our technical data sheet, or of course, contact us and we can give you further details.
Awesome. Thank you, Sam. One of the great joys for me personally of working at Nexa 3D is working with a materials partner like Henkel with Loctite and seeing what we can develop together that can really meet the needs of the industry and how we can hit those really high bars of exactly what manufacturing applications require. I'm seeing a few more things coming in the chat, and I'd like to just remind everyone to please put your answer or your questions in the Q&A box in the Zoom tab that you'll see at the bottom of your screen. It's right next to the chat box, so please put them in the Q&A, just so I can kind of keep everything straight. That would be wonderful. So we've talked a little bit about what it took to bring all of these pieces together. We've got Nexa 3D, we've got our materials partner Henkel, we've got Dynamism, our reseller and very close partner, and then we've got the user, the customer, PepsiCo. That's a lot of pieces on the chessboard, right? And of course, we always see chess pieces, very keen in 3D printing these days. And of course, if you want your own XRook piece, go to nexa3d.com and you can sign up and get your own free sample of our materials and check out what the platform can do for you. Just want to drop that in. But as we do this, I'd like to jump into, we've got all these players, right? We have all of these people on this call right now. We've got all of these players on our chessboard. So PepsiCo, Max, Tanti, what is this doing for you? I'm going to go back to another slide that you've provided so we can jump into actually why we're talking about this today. Why does this make a difference? The number that's showing up on my screen and hopefully yours is a hyper compelling number. 96% tool set cost reduction. Max, Tangti, can you speak to this a little bit? How did we get there?
Yeah, sure. So before, so after we get a design that we want to move forward with prototyping, what we do is we typically order a unit cavity mold, and typical cost depending on the mold complexity can be 10,000 or even higher. So we're benchmarking it against a metal mold because of the quantities that we can produce with our 3D printed mold set. And that's the big difference. In prior attempts, you were only able to print 100 to 200 samples with a 3D printed mold set. But because of the material and the HTT properties and the mechanical properties and the way that our modular mold set is constructed, we're actually able to produce quantities that are comparable to metal tooling. And thus, we're comparing the tool set cost to metal tooling.
And we have another compelling percentage point for you, which is 93% time reduction. Can you speak a little bit to what that means?
Yes, sure. So for us, we go to, again, outside service providers, typically to manufacture our mold set. And from the time that we're ready to proceed forward to the time that we actually get a part, get the molds, it could take about 4 weeks. In comparison, our entire process of 3D printing and assembling the mold is within 48 hours. And that's where we've demonstrated a 93% time reduction.
Okay, so Max, when we're talking about that 48 hours, what exactly is included in that? That used to take 4 weeks because there's a lot in there, right?
Yes, absolutely. So it's in our internal process of being able to get our files approved and released to our to our service provider. Our internal process of being able to issue a PO. Their process of being able to get the metal stock and reserve time in their subtractive manufacturing process. The finishing step that it has to go through, polishing, all of that takes quite a bit of time. And you could possibly reduce that if you look at the administrative tasks. But even with that reduction, you cannot meet the internal process of 3D printing.
So a lot of times when we talk about how 3D printing plays well, You know, what is it that they say on report cards? Plays nicely with other kids. When we talk about how 3D printing fits into that kind of report card, a lot of times people want to say that 3D printing is replacing traditional manufacturing, is replacing blow molding, injection molding, name a manufacturing technology, right? But what we're seeing with PepsiCo right here and what you've designed is this very clever implementation where they play nicely together. So can we speak a little bit to how the power of these technologies really coming together informs what you've been doing and how that actually has a substantive impact on ROI at a company like PepsiCo, which again, like we all know PepsiCo. If you go to Taco Bell, you know Pepsi. Like,
Right, so additive manufacturing is an enabler in our entire process. What it allows us to do is it allows us to go to our lab scale, internal lab scale, instrumented stretch blow molder, and get the learnings that we need so that we can understand the impact that this new design or this new material or this new preform might have downstream in our full supply chain production operations. And by getting those early learnings, we can make changes or we can decide to make modifications and speed up the iterative process that we need to go through, so that when we actually go into the manufacturing environment, we have a significant confidence, a high level of confidence that we're going to get it right the first time, as opposed to going in there blind and tweaking and doing trial and error studies and trials and having to repeat them. So that's where the power of 3D printing and additive manufacturing is coming in. It's facilitating that capability so that when we go in to a plant environment, we know we're going to be successful.
yeah, I love that. And so, Max, talking to you, I want to dig in a little bit more on this slide in particular, when we're talking about the benefits of bringing additive manufacturing into these blow molding processes. 96%, $350 versus $10,000. Obviously, mathematically, a 96% reduction. Can we speak a little bit to where those numbers come from? And Fratch, please feel free to chime in. I know that you've had a hand in this as well. So I just want to look at the math behind this. What are these numbers comparing to?
Well, I can speak on behalf of the material cost from the Nexus material list. You know, what Max said earlier is it could cost up to $10,000 to generate a mold, a single mold, versus printing with the inserts using the XPeak material. And I see a lot of different questions in there asking for the prices of the materials and how much it costs and all that. I'll be happy to provide you guys with all the costing after. Feel free to reach out to me. And what we do at Dynamism is we pretty much do the ROIs. We eliminate all the questions before the purchase of the equipment. You know, we provide you with the samples. We tell you do a cost analysis on how long it takes to print, how much the materials cost, and then we turn that information over to the end users and have them compare it to their current process and kind of get the percentages that you see on the screen.
Yeah, awesome. And same for the time reduction we're seeing here, 93%, 4 weeks to 48 hours. Significant.
Definitely. And what we experience with a lot of end users is a lot of customers or a lot of end users are using outsourcing service bureaus and so forth. And then lead times there are pretty long, especially nowadays with everything going local manufacturing. We see up to 8-week deliveries on some of these parts that they request. Having the equipment in-house allows us to really turn around those samples and get these parts directly to the end users for testing and ROI numbers. And we usually are under 2 weeks when printing samples and getting these parts into customers' hands for either production or actual testing.
So I feel like it's safe to say we have the math behind these, right? We have the math behind this 96%. We have the math behind this 93%. For someone who hates math, it's an English major. You know, that it's significant to have people be able to substantiate figures like those. Those are really notable. So the thing I'd like to move into next is actually talking to you. I'm pointing at my webcam. I'm pointing to you. Those of you who are joining us live today, we have several questions in the Q&A box right now. I invite you, everyone who's with us live, look at the bottom of your screen. There's a Q&A box. Please pop into that right now. We welcome questions for Nexa 3D, for PepsiCo, for Dynamism, for Loctite Henkel, to talk about all of these areas. So we have several questions in already, team, that I would like to direct to those of you who were kind enough to join us today. And so where we're going to start is with a question that I've already lost, and I'm scrolling so quickly. I apologize, and thank you for your patience and staying with me. We have a couple of questions about the safety of the 3D printed products that we're using in these molds. So has there been any testing on a long-term production environment basis or development and lab quantities only? And can any material Henkel makes be used for food contact? So we're looking at safety and the food contact capabilities of materials being 3D printed today. Sam, I'm going to kind of kick this over to you to start.
Sure. Yeah, I was just looking at the questions. I wasn't sure how you wanted to address them. Just real quickly on incidental food contact. This is a government FDA or European. So the answer is right now, no, we do not actually have the full certification for food contact because each, there's a lot of regulations depending on, is it contact directly with the food or is it in packaging? So I would encourage that individual or anybody who's looking for that to maybe reach out to Nexa or Henkel, and we can give you more details. We can test for that, but it's a wide sort of spectrum on the regulations and what specific the customer would need.
Thank you, Sam. We've got another question in about when did Pepsi first start 3D printing blow molds? How long has it been that your huge company that has so many bottles across so many product lines saw 3D printing, additive manufacturing as a benefit for creating the blow molds to produce your new bottles?
You know, that's a great question. We've been on this journey for about 5 to 6 years, I would say, with FDM style printers at the beginning and carbon reinforced filament. That was our first start, and that was about, I would say, around 5 years ago. Prior to that, we were machining our mold sets, and we're working with a small lab scale blow molder down our design center. But again, in terms of really accelerating our program in this area, I would say it's probably within the last 3 years when companies like Henkel started to support really the materials that are needed. And the advent of photopolymer technology really took off and made it viable to look at additive manufacturing as a potential solution.
I'm going to bring us back to this slide for a second because we have a question in about, what is it? Cost of the tool set, $350. Can't believe it because of resin peak costs and hour rate on the printer.
Yeah, no,
So
that's
can we talk a little bit about that?
that's a good. It's a good challenge. You have to look at the way that we've constructed a mold set and how light the parts are that we print. We're printing two shells and a base, so we're not utilizing a significant amount of X peak material during our printing process. If we were printing the entire mold, I would say that yes, you start to get into a significant amount of material cost, but we're only printing what we need, which is a very slim layer, a very slim shell. And then we're filling the void, the metal outer casing and the 3D printed shell with a very low cost dental stone material. Think of it like plaster, if you will, but it's very low cost. So in terms of material costs, we're minimizing the amount of PEEK material that we use, and we're filling it with very low cost material to keep the costs to that within that 350 range that we quoted.
Another one that fits right in here, Max and Tangtip, is how often are you producing new molds and designs?
I'll let Tangtip answer this question because it's been nonstop, but she's got the numbers for it.
Yeah, so it's pretty much been nonstop ever since we got our lab scale blow molder in February. So ever since then, we've been able to do 8 bottles now, which is something that is unheard of with our conventional methods of producing molds.
So, I mean, that's pretty substantial, especially for a company like PepsiCo that has so many brands and so many different designs that require so many different bottles, and that keeping up with the times is its own thing. So for being such a busy global company as PepsiCo is, having all of these designs available to do and redo and brands to do and redo, and being able to do 8 at a time, that's notable. That's notable. So we'll dig back in here a little bit for some more questions. Got one coming in. What is the biggest takeaway or learning from Pepsi that you would share to other companies who are looking to use a hybrid AM and subtractive or molding approach for developing tooling?
I mean, we take lessons and learnings from different industries. So for example, in the injection molding industry, it's been widely used, the concept of mud tooling, where you utilize inserts to be able to generate the part. The use of PEEK material is something that's been used in automotive. And even there, we're expanding our capability by looking at increasing the mechanical properties through mechanical electroplating, mechanical coating. So we look at a host of different industries to try to get some inspiration and look at what else can we exploit. And we rely on the industry experts, are the ones that have a keen eye and a keen pulse of what is happening, like dynamism, to fill us in on stuff that we may not be able to see, because we're end users. We're not doing this on a day-to-day basis. But yeah, we try to take as many inspirations as possible from other more experienced players.
One of the other questions we have in for that end use perspective, Max, is, are there any differences in the factors of control for the blow molding process in terms of shrinkage or thermal properties in comparison to the original metal cavity, and what are the limitations?
Yeah, sure, absolutely. So with metal tooling, you have the thermal conductivity, right? And that's the major one. With XP being an insulating material, you don't have the same level of thermal conductivity. So what we need to do is we need to figure out how do we cool the part in order to control the shrinkage. And there again, what we do is we compensate by going from conduction into convection. So what we do is we inject air through the stretch rod during the blow molding process. And with that, we're able to almost comparably to what you would get in terms of the cooling in the conventional process.
Awesome. Let's see some of the other questions we've got. We've got a question about how can Nexa 3D printers be a substitute in rapid prototyping, medium production, substituting SLS and polymer powder printing in terms of lead quality, lead time, quality, and performance. I know my answers, which absolutely involve the fact that we are bringing a production-focused SLS printing platform to market very soon. So please keep an eye out for the QLS 820. But before I get into it from our inside perspective and get too in my head and in my company, Gretch, I'd like to hear the dynamism perspective here and how your company has seen the platforms that you provide and connect customers with to cases in rapid prototyping, medium production, and coming in play in place of other solutions.
Right, and that's a really good question, because on a daily basis, we deal with a lot of different customers, you know, everything from Pepsi's to mom and pop shops, and everyone has certain kind of challenges. Part of our job, the part of what I enjoy doing, is understanding the difficulties of each or end user and what they need. You know, some could be prototyping needs, some are production needs, and that's how we kind of evaluate the equipment, figure out which materials are needed, and do all the testing for, or provide the parts for the customers to do all their testing and the data as well to match their current needs, you know. So it's a broad question to answer. I mean, I don't have a really great answer for that, but that's what Dynamism's job is to figure out and provide all the needed data to make you know, an educated decision on how to move forward with the production needs.
No, thank you. That's, I think, really helpful, because as you point out, you know, there isn't an answer for that. It is really broad. And as you know, as we've kind of been honing in on throughout this, or maybe dancing around throughout this last 45 minutes, it's the right tool for the job, right? What we really need to find is the best way for things to work together to get the best value for the person who's doing the work. And a lot of times, a lot of times, it's not a drop-in solution. It's finding ways for new solutions, existing solutions, to come together, to get together with the right materials for the right customer through the right connection, like Dynamism, to really build something super special that gets us to those 93-96% reduction rates in terms of cost and time. So one of the other things that we're coming to, question-wise, Sam, I'd like to direct to you. We have a question in about current AM methods as they regard to plastic recycling and current challenges faced with these methods. I know that Henkel is on this journey with us toward a more sustainable world, and you're absolutely leaders in this space. So I would love to hear your thoughts as a material supplier, where recycling, reusing, and reconstituting materials in the plastic waste stream comes into play here.
Yeah, I mean, as everybody knows, it's a really large open topic, and Henkel is very committed to sustainability across all of our products and our polymer products. Specifically for our 3D printing resins, we do have a group that's focused on sustainability, starting really with looking at more like bio-based materials. So essentially creating resins that are really using, you know, a percentage 50 and hopefully 100% of bio-based materials. That's something we're working on. We haven't launched that yet. One of the challenges is that all of our products are thermosets, they're not thermoplastics. So in terms of taking a finished product and then, you know, and sort of breaking it down and reusing it, that's really a work stream that is being looked at by the greater Henkel because of what we do with adhesives and other things. And then, of course, looking at the packaging as well. So unfortunately, there's not a lot of time to give the real deep details, but I would say the things that I'm most excited about are really looking at, you know, bio-based types of materials. And I believe that in the short term, there'll be products coming out that actually have the performance, because that's the real key thing, is the performance that people need, but based on these types of additives or starting points.
Definitely. No, that's really helpful. Thank you, Sam. Max Dungty, one of the other questions we have coming in hits onto that limited number of shots that we tend to see available when it comes to 3D printing involved in molding designs like what you've done. And we know that you've validated more than 10,000 shots using the process with the NXC 400 platform, the XP 147 material from Henkel, and your patented process. How did you get up to 10,000, and what benefit does that bring to PepsiCo?
Yeah, so in order to be able to, why 10,000? Well, those are the quantities that we actually need if we decide to go in and do a limited production run. Our lines tend to run at a very high speed. And in order for us to be able to get learnings on the performance of that particular package in our manufacturing environment, we need those level of quantities to be able to run for half an hour and get those learnings. And the ability to get up to those quantities is based on the construction of the mold set. So we're typically running it at 40 bars of pressure, so 620 PSI. But most of that pressure is being absorbed by the modular mold construction, the outer metal shell, and the compressive material, the dental stone material that we put in between. So we're actually spreading the load very evenly between the material selection that we've had. And that's what allows us to be able to get up to those high cycles.
Awesome, thanks, Max.
And just to add to that, what we've experienced is every molding application is different. Design, thickness of the part, the temperatures that you're running your blow mold, or the material that you're actually blowing in, that can vary the end result of each printed part. So as mentioned before, every situation is unique, and that's why we're here to help you guys with different iterations, different design suggestions to kind of put all that together.
I think we'd all be lost without someone like you, Rich, to point us all in the right direction of how these things work together. We have just a couple of minutes left, so we'll kind of do a speed through for some of the remaining questions that we have in the Q&A box. If you have another, front of mind question for us, this is your last chance. Please throw it in the Q&A box right now on the Zoom. So one of the ones that I'm going to go ahead and tackle is some blow molded parts are quite large. Do you foresee limitations for insert sizes? So Max, Sandeep, of course, I absolutely welcome your input as well here. But one of the reasons that we really brought the NXC 400 and its slightly little brother, the NXC 200, to market is to bring a larger build platform to people who need it. And having, the specs that you need, the build volume that you need at hand, so that you don't hit those limitations that you might on other systems or on other opportunities available on the market today. We want you to be able to reach your dreams, and sometimes those dreams are really big, and they require a build volume to fit. And it's not to say small parts are small dreams, but when you're dreaming, large volume, you need something that can really hold all of that together. When it's a mold insert, there's obviously the expectation that it will fit inside that larger mold itself, but we don't want you to be limited by that build volume. We want you to have that entire Pepsi bottle on a single build volume. So Max, Sandeep, how have you really seen that build volume limitation coming into play when you bring 3D printing in?
I'll let Tacta take this one.
Yeah, sure. So for our current design, it's limited to 1 liter bottle sizes. Because of the way the modular mold is designed, we are able to scale that up to larger sizes, up to 2 liters. So in terms of bottle size limitations, it's something that we can address by scaling up the overall modular mold design. But currently right now, because of the build envelope of the NXC 400, I don't foresee, that size being unable to print on the current printer that we have.
Awesome. We have actually hit time with that. So I know we still have a few questions in the Q&A box that we weren't able to get to today. But I'd like to reiterate that these are your speakers today. I'm Sarah Gerke with Nexa 3D. We've had Max Rodriguez and Tangtip Tekanil with PepsiCo, Rach Kasparian with Dynamism, and Sam Bale with Henkel Loctite. We are all here for you. Please reach out to any of us. We're all very easy to find. Stop in at nexa3d.com. Here's Dynamism's info. If you'd like to reach out to Rach and his team. The presentation that you've seen today will be available as a recording to you very soon. It will be sent to everyone who registered today. And we're so grateful for your time. We do welcome your outreach at any time. If there's anything lingering in your mind that we didn't get to, please reach out to any of us. Sam, Rach, Max, Tangtip, thank you so much for joining us today. It was a true pleasure to talk again with you all. And I look forward to continuing to work with you all, because from Nexa 3D, it is our pleasure to continue this relationship well beyond just talking about it, but actually doing things and making a difference together.
Okay. Thank you so much.
Thank you, Sarah.
Thank you all for joining us today. It was really wonderful to see you all. Please reach out, and from Nexa 3D, as well as all of our partners, thank you for joining us in today's live webinar, and we look forward to seeing you again very soon. Have a wonderful rest of your day. Bye.
Thank you. Bye.